Hello everyone, I'm Dr. Shaik Ruksana Begam, working as Assistant Professor in the Department of Electrical and Electronics Engineering from Institute of Aeronautical Engineering, Hyderabad. Today I am here to deliver a lecture on mesh analysis. So first, before solving the mesh analysis problems, first we have to know what is a mesh. So what is the difference between mesh and loop? So generally mesh is a circuit which allows the flow of current. So it is a closed path which allows the flow of current into it. Loop is also similar to mesh. A loop is nothing but which allows the flow of current when it is in closed path. So how to know the difference between mesh and loop is, see, if there is a circuit, so if we consider the same circuit here, so here we have two meshes. How to say two meshes means, mesh is nothing but a closed path which allows the flow of current. So if we denote it as A, B, C, D, E, F. So here are the two meshes, which is of mesh 1 is taken as A, B, E, F. And if we go for mesh 2, it is considered as B, C, D and E. So now what are the loops? See here there are two meshes which allows the flow of currents. Now if we consider loop, here we are having three loops. How? See, already we have seen two meshes. Meshes are nothing but loops. This will come under loop also. So what is a third loop? So loop is nothing but which allows the flow of current. Here there are two ways. See, if we consider this loop also, so this is also a path where the current is flowing. So loop 3 will be A, C, D and F. So these two are the loops and the third loop will be A, C, D, E. What is the difference means, a mesh can contain only one loop. You have to know that the mesh will contain only a single loop. A loop can contain n number of meshes in it. So the difference is, a mesh can contain a single loop, but a loop can contain n number of meshes. So here if we consider this path as a mesh, so here is only one loop. And if we consider this path as a mesh, again here we are having only one loop. If we consider this whole circuit, we are having two meshes. So if we consider only one loop, a mesh can contain a single loop. The loop can contain n number of meshes. From this we can know that all meshes will be loops, but all loops cannot be meshes. So here is the statement: all meshes can be loops, but all loops cannot be meshes. We have to remember this point. So first, going for the definition of a mesh, in a circuit analysis, a mesh is a loop in a circuit that does not contain any other loops in it. So what we have, so what is given in this definition? In a circuit analysis, a mesh is a loop in a circuit that does not contains any other loops within it. So again, mesh or the mesh current method is a technique used to solve the unknown currents. Why we are using mesh analysis means, to calculate the unknown currents in the circuit, we are using the mesh analysis. In the upcoming classes, we'll be solving complex problems which will be having a number of meshes. So in that meshes, we are going to calculate the currents. So the mesh analysis is used to calculate the currents in the circuit. So again, a loop is a closed conducting path in a circuit. So the difference between loop and mesh is a mesh can contain only a single loop and a loop can contain n number of meshes. So all the meshes will be equal to loops, but all the loops cannot be equal to meshes. So we have to remember this point. So here are some steps to solve mesh analysis. So if we go for the steps to find the current flowing in the circuit using mesh analysis. So first step will be we have to identify the loops or meshes in a circuit and label a mesh current to n meshes. So if we are having n meshes, we have to first find out how many meshes are there in the circuit and we have to label it with mesh currents. So if we are having three meshes, we have to label it as I1, I2, I3. If we are having n number of meshes, it can go on till In. So first we have to label In. What we have to label the circuit. Then first we have to find out the meshes in the circuit and we have to label it with currents. So second one, apply KVL to each mesh with the corresponding mesh current to generate n equations. So apply KVL to each mesh with the corresponding mesh current to generate n equations. So we have to apply KVL in the each mesh and we have to find out the currents. In the third step, we have to solve the resulting simultaneous linear equations for unknown mesh currents using Cramer's rule. So here we can use Cramer's rule or either we can calculate it by using the equation methods directly. We can substitute in the calculators and we can get the values of the mesh currents. If we are having n mesh currents, we will be finding for the n meshes by using the calculators. We should use only scientific calculators. In the scientific calculators, we can directly substitute the values and we can get the values of currents or voltages. So I'll explain you that in the next slide. So now we have seen that first mesh analysis is used to calculate the mesh currents in a circuit. If we are having n mesh currents, n meshes, we have to calculate n mesh currents. So what is the difference between loop and a mesh? So I have already mentioned a mesh will contain a single loop and a loop can contain n number of meshes. So a mesh is nothing but which allows the flow of current to flow in the circuit. It is a closed path. So here are the steps. First step, we have to identify the meshes in the circuit and then we have to apply KVL across each mesh and we have to calculate the I1, I2, I3 currents by using Cramer's method or by using scientific calculators. We can also calculate the currents. So here we'll be seeing the first example how to calculate the mesh currents using mesh analysis. So here is the first example. In the circuit shown in figure, determine all branch currents by loop current analysis. Loop current analysis, or it can be also taken as mesh analysis. So if we see the circuit, here we are having, if we denote it as A, B, C, D, E and F. So first, how many meshes are there in this circuit? So this is the mesh 1. It will be taken as A, B, E and F. So if we take mesh 2, it will be of B, C, D and E. So here is the mesh 1. I am denoting it as I1. Here is the mesh 2 which I am denoting as I2. So here for calculating the mesh currents, first we have to take the direction of the currents. The direction of the currents may be of clockwise or anti-clockwise. Basically, the direction of the currents are mostly taken in the clockwise direction. So first we have to represent the direction of the current. So if we take in this way, the direction of the current will be of clockwise. So the current is flowing from negative to positive. Remember a small trick. If the voltages are negative, voltage is negative, all the resistances will become positive. generally to remember, I'm telling. So this is a small trick to remember. If the voltages are negative, all the resistances will become positive. So here is the direction. I have taken it as clockwise direction. Here it is flowing from negative to positive. Then we have to write the mesh equations first. So first the voltage is negative, minus 50, and the current is flowing here. So the current flowing in this resistance will be of I1. So I'm taking it as 3I1. Again it is flowing here. Here it is dividing. So again I'm considering only this this mesh. So I'm taking only for this mesh I1. So again if we consider the resistance at 5 ohms, the currents will be. So as I'm considering for the first mesh, I'm taking it as 5I1 minus I2 will be equals to 0. So I have taken equation for the first mesh, and now I am taking for the second mesh. So if we see the direction, it is also in clockwise direction. If we consider the first mesh as a clockwise direction, all the other meshes we have to consider the same direction. It may be clockwise or it may be anti-clockwise. If we consider the first mesh as a clockwise direction, all the other meshes will also become clockwise direction. All the other meshes also we have to consider it as clockwise direction. If we take it in anti-clockwise direction, all the other meshes also we have to consider it in anti-clockwise direction. So now I'm calculating the equation for mesh current I2. So first I'm taking for 5 ohms, as if I'm considering for a second mesh, I'm writing it as I2 minus I1 plus the current flowing in the 2 ohms resistance will be of I2. So up to I2 will be equals to 0. So first we have to substitute this equation. First we have to calculate add. We have to sum all the I1 currents and I2 currents. We are having a number of currents, so we have to sum all the currents. So first I am taking I1 current. So here it is of 3I1 plus 5I1 minus 5I2 minus 50 equals to 0. So if I sum all these two currents, so 3I1 and 5I1, if I sum, I am getting 8I1 minus 5I2. If we take minus here, we'll be getting 50. So this will be the equation 1. So if I calculate same for equation 2, so here I am taking 5I2 minus 5I1 plus 2I2 is equals to 0. So here I am summing I2 values. So minus 5,1 I am taking as it is. So 5 plus 2 it will be of 7I2 equals to 0. So this will be the equation 2. Now we have to sum this equation 1 and equation 2 by using Cramer's rule, or by using a scientific calculator we can substitute these equations directly. So how to substitute the equation by using the calculators means, so here is the scientific calculator which we'll be using to solve the problems. Here is the mode setup option. If we click this mode setup option, in this mode setup option, we have to select option 5, which will be of equation. So if we select equation option, these 4 options will be displayed. So depending upon the equations which we are having, now if we consider this equation, we are having only 3 values. So as if we are having 3 values, we have to select this first option. So here is the value 1, 2 and 3. If we are having 4 values, then we have to go for option 2. So if we select this option, the equation mode will be get displayed. In that equation mode, we have to substitute all these values and then we'll get the values of I1 and I2. So after substituting the values, so first equation will be of 8I1 minus 5I2 is equals to 50. 8I1 minus 5I2 is equals to 50. This will be the equation 1. And if we go for equation 2, it is of minus 5I1 plus 7I2. Minus 5I1 plus 7I2 equals to 0. This will be of equation 2. Now from this we have to substitute the values of I1 and I2. So after substituting these values in the scientific calculator, we'll get the values of I1 and I2 as. So the I1 value will be of 11.290 amperes and I2 value will be of 8.60 amperes. So while considering the values of I1 and I2, we have to take at least minimum 3 decimals. So here I have taken 11.290 amperes as I1 current and I2 will be of 8.60. I2 value will be of 8.06 amperes. So now I have to calculate the current in the circuit in the resistance value. If the resistance value is of 5 ohms, what is the current flowing in this circuit? So if I take the equation with respect to 50 volts, the equation will be of I1 minus I2. So now I have to calculate the current across 5 ohms resistors. Now I am taking it as I1 minus I2. Current at 5 ohms resistance. Then I'll be taking it as I1 minus I2. Then the value of I1 will be of 11.290 minus 8.06. So the current across 5 ohms resistance. So if we calculate current across 5 ohms resistance, the value will be of 3.23 amperes. So in this way, first we have to identify how many meshes are there in this circuit, and then we have to calculate, we have to denote the currents of each mesh, and we have to apply the KVL. After applying KVL, we have to calculate the equations of each mesh currents, and then we have to substitute the values by using scientific calculator, and then we have to get the values of I1 and I2. If there are n number of meshes, we'll be getting till IN. So if we move for the second example. So in the previous question, we have seen if we are having only one source, so how to calculate the currents in each mesh. Now in this circuit, we are having two sources. So the question is given as in the circuit shown in the figure to determine all branch currents and voltage across 5 ohms resistor by using loop current analysis or mesh analysis. So here we are having two meshes. So I have denoted this as mesh I1 and this will be I2. If we consider loop, we will be having 3 loops which will be of whole circuit. So this whole circuit will also become a loop, but we are applying mesh analysis. So I am considering only 2 loops as a mesh contains of only a single loop. So this will be loop 1 and loop 2, and I am taking the direction of the current as a clockwise direction. So in this we are having two sources. So if we are having two sources, we have to consider the main source. So the source at the first mesh as a main source. So if we take upon the direction of the current is flowing from negative to positive. Again here the current is dividing. So that I am taken as I2. With respect to 50, the current across the 5 ohms resistance will be I1 minus I2. So now we need to calculate the mesh currents in mesh 1 and mesh 2. If I consider mesh 1, so the equation of the mesh 1 is taken as, so the current is flowing from negative to positive. I am taking it as 50 minus 50 plus the current across 3 ohms resistance will be of 3I1 plus if I consider 5 ohms with respect to first current, I am taking it as I1 minus I2. And the current flowing in the 6 ohms will be of plus 6I1 will be equals to 0. So if I consider equation for the second mesh, so with respect to mesh 2, it will be of the resistance across this is 5 ohms. phi I2 minus I1. So with respect to I2 I am taking, so I am calculating it as I2 minus I1 plus 2 I2. So as it is flowing in clockwise direction, the voltage is taken as plus 25. So again the current flowing in the 8 ohms resistance will be taken as 8 I2 will be equals to 0. So first we have to calculate these two equations and we have to take out the values of I1 and I2. So after solving these equations, we'll get it as, so if I take for the first equation, so it will be of 3I1 plus 5I1 minus 5I2 plus 6I1 equals to 50. So now I am summing all the I1 values. So 3 plus 5, it will be 6, 14. So here it will be of 14 I1 minus 5 I2 will be equals to 50. This will become equation 1. Now I am solving equation 2. So 5 I2 minus 5 I1 plus 2 I2 plus 25 plus 8 I2 equals to 0. So I am summing all the I2 values here. So it will be of minus 5 I1 plus 50 I2, and if 25 becomes minus 25, this will be equation 2. Now we have to substitute all these two equations in the scientific calculator, and by using the scientific calculator we are going to extract the values of I1 and I2. So first we have to substitute this. Here also we are having three values, then we have to go for the option mode setup, and then we have to select the fifth option which is of equation. And then from that we have to select the first option as if it is the here we are having only three values. So after substituting these three values in the equation, we'll be getting I1 value and I2 value. Yes, after substituting these values in the scientific calculator, we'll be getting the values of I1 as 3.378 amperes and I2 value will be of minus 0.540 amperes. So I have already mentioned minimum we have to take at least 3 decimals after a point. So here I have taken 378 and 540. So the value of I1 will be of 3.378 and I2 will be of minus 0.540 amperes. Now in the question they have mentioned, so we have to calculate the all branch currents and the voltage across 5 ohms resistor. So before calculating the voltage across 5 ohms resistors, first we have to calculate the current across 5 ohms resistance. The current across 5 ohms resistance will be of, see, I1 minus I2. So the value of I1 is 3.378 minus of 0.540. So if we calculate the current across 5 ohms resistance, we'll be getting, so if we calculate the current across 5 ohms resistance, here is 3.378 will be the value of I1 minus of minus, it will become plus. So 3.378 plus 0.540 will become 3.918 amperes. So now we need to calculate the voltage across 5 ohms resistance. So general formula for voltage is V is equals to IR. So the value of I is given here. So it will be of 3.918 into 5. The resistance is 5. So the voltage across 5 ohms resistance will be of, so the voltage will be 19.59 volts. So from that question, first we have calculated the values of I1 and I2, and in the same question they have mentioned to calculate the voltage across 5 ohms resistors. So 5 ohms resistor is connected in between mesh 1 and mesh 2. To calculate the current across the 5 ohms resistor, we have to consider the first source as a main source. Then we have to take I1 minus I2. We have to substitute I5 ohms will be of I1 minus I2. So we have to subtract these values. So already we are having the I2 value as negative. So the negative minus into minus will become positive. So we have to calculate 3.378 plus 0.540, and we'll get the value of I at 5 ohms will be of 3.918 amperes. From that we have to calculate the voltage across 5 ohms resistor. The general formula of calculating the voltage is V is equals to IR from the Ohm's law. So we have to substitute the value of I and R, or already we know that it will be of 5 ohms. Because we are calculating across 5 ohms resistance, we have to substitute the value, and we got the I current value as 3.918. We have to substitute the same value, and the voltage across 5 ohms resistance will be getting of 19.59 volts. So that's it for the today's session. We'll be calculating more examples on mesh analysis in the next section. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.